Hi everyone, welcome to video 1 for linear functions, slopes, graphs, and models. So in this first video, we're going to revisit slope-intercept form, and hopefully you recall that our slope-intercept form for a linear equation is y is equal to mx plus b. B is going to be your y-intercept. And if you recall a y-intercept, if we look at it from the perspective of a coordinate point, this is where the x value in your coordinate point is equal to 0, and then y will be some number. It could be negative, it could be 0, or it could be positive. Our slope is denoted by m, and if you recall, slope is found by doing rise over run. Rise meaning the vertical change in your y values, and the run representing the horizontal change in your x values. This is why we use the formula y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Literally the vertical change over the horizontal change. So let's move on how to graph a linear equation in slope-intercept form. The nice thing about this form is that you have all the information that you need and you really don't need to do any calculations. So the first thing that I would note is what the y-intercept is. So in this case, the y-intercept is 4, so that means that I have a starting point at point 0, 4. The slope is going to tell me how to move. So if I look at 1/3, I'm going to look at the sign of the number and also the location. So a positive 1 means that I'm going to go up 1 unit. And then the 3, since it's positive, it's telling me that I'm going to go to the right 3 units. And I can do this from my y-intercept. So I can go up 1, and then over to the right 3, and here is my next point. And I can continue to do that as long as I have space on my graph. I can just keep putting those points, as many as I want. I could also go in reverse, so if you kind of run out of space on the right-hand side, you can always move to the left. What you want to do is you just want to reverse both of those directions. So I'm going to go down 1 unit and to the left 3 units. And again, we can kind of see that happening if I start from my y-intercept down 1 to the left 3. It's going to continue to give me all these coordinate points. And notice that by doing this, I've created a consistent line. The slope is going to tell me how to move. So with a slope of 1/3, I want to look at both the position of the number and the sign of the number, whether it's positive or negative. Since this is a positive 1 in the numerator, that's telling me I should go up 1 unit. And since I have a positive 3 in the denominator, this is telling me to go to the right 3 units. Remember, rise is going to be up and down, run left and right. So from here, I'm going to, from my y-intercept value, I'm going to go up 1 unit and to the right 3 units, and that's going to give me my next point on my line. And I can continue to do that, so go up 1, right 3, up 1, right 3. If you run out of space and you want to add more coordinate points, you can also go in kind of a reverse motion. So if you want to go in reverse, you're essentially just going to go down 1 unit and left 3 units. So again, from our y-intercept down 1 unit to the left 3 units, and I have my next point. And again, I can continue to do that as much as I wish, so you do not need to include all of these points. But notice that the more points I have, the easier it was to draw that straight line. Keep in mind, if we are given a function where it's just y is equal to 1/3 x, this is also a linear equation. And you might be asking yourself, well, where's the b in this? If we don't see that y-intercept, we can simply say, well, there's nothing there, so we can just put a +0 there to hold the space. This tells us that our y-intercept is actually at the point 0, 0, or the origin. And again, since I have the same slope, this is telling me that I would go up 1, right 3, and I can keep doing that as long as I would like, or I could go in reverse and go down 1 to the left 3, And I like to add a lot of points because it makes it easier for my eye to connect those points and get a nice straight line. So notice that in this result, I still get a linear function. Say I do give you an equation where it's y is equal to 1/3 x. And you might be asking, well, where is that plus or that minus b, or my y-intercept? If I don't see it, and you do need to kind of make space for it, feel free to add in a +0 so that you kind of fill in all of those pieces. This tells us that our y-intercept is at the origin, or point 0, 0. And from here we can go through the same motions of going up 1 to the right 3 in order to populate more points for ourselves, or respectively go down 1 to the left 3 if we want to fill in some points on the left of that y-intercept. I like to include a fair amount of points just because it shortens the space between the points, so I'm more likely to draw a nice straight line. Notice in this case when I'm comparing both of these functions, which are both linear by the way, they end up being parallel to each other. So I'm going to leave the question for you of how do I know that just by looking at the linear equations that I have here, that they would be parallel to one another. Let's move to the next question. So in this question we want to find a linear function whose graph has a slope of -5 and a y-intercept of 3. So when you're given these pieces, you end up actually just kind of slotting these into like a really easy puzzle. So first off, they're stating that we want to do a linear function. So that tells us that our structure should be y is equal to mx plus b. Next, they tell us that we have a slope of -5. So this is going to give me y is equal to -5, and then x. And we have a y-intercept of 0 and 3, so we actually already have the rest of this. So we can do plus 3. Here's our linear equation. And again, we're able to do this because they explicitly gave us the slope and they explicitly gave us the y-intercept. So again, if we wanted to go ahead and graph this, we know that we're going to start at +3 on the y-axis. A slope of -5, if you want to create that ratio so that you can see the rise and the run, I would just put a 1 over it. That's the quickest way that you can make a integer value like -5 look like a fraction. So this is telling me to move down 5 and then to the right 1. So I'll go down 5 and then to the right 1, and I can continue to do that if I want. Likewise, I could go in reverse, so I could go up 5 and then to the left 1. And again, all of my points are kind of lining up nice. Oop, my line, however, was not. That's a little bit better. But now I can see that I do have my linear equation, or my linear function, graphed. I do want you to note the direction of the line. So notice that since the slope was negative, as you read the line from left to right, it is pointing downward. This is different compared to the last example that we had where the slope was a positive 1/3. So notice that as you read that line from left to right, it goes in an upward direction. For the next part of the lesson, I want you to be aware that not all linear equations are going to be presented in slope-intercept form, but that doesn't mean that we can't manipulate it or rewrite it so that it is in slope-intercept form. The form that you're looking at right now, 2x plus 8y equaling -24, is in standard form. Here's what we need to do in order to get this into slope-intercept form. Remember that slope-intercept is going to be y is equal to mx plus b. So that essentially tells us that we need to get y completely by itself. So in order for me to start that off, I can remove any term that does not have a y in it. So I'm going to subtract 2x from both sides. So this is going to give me 8y is equal to -2x minus 24. Remember, those two values cannot be combined because they are unlike terms. One of them has a variable and the other does not. The next thing that we want to do is we want to get rid of the 8 that's being multiplied with y. So I'm going to divide both sides, and on each side, each term gets divided by 8. So this is going to give me the result of y is equal to, well, -2 over 8 can be reduced down to a -1/4, and then -24 divided by 8 would give me a -3. Notice now I have this in slope-intercept form, and I can quickly graph this. I can start at -3 on the y-axis and then go down 1 and then to the right 4. And then I can keep plotting points in that way. So for the remainder of this video, everyone, I have a couple of you-try problems. So the first set is located here for you. We want to determine the slope and the y-intercept of the equation and draw its graph. If you need to, feel free to grab some graph paper, or you can do a quick Google search and you should be able to pull up some graph paper for yourself to print off of. But go ahead and work on this, and when you are ready, press play and we will review. So for our first problem, it's already in slope-intercept form, so it's easier for us to quickly identify the components that we need in order to graph this line. So for instance here, since we have our -2, that tells us that our y-intercept is going to be at the point 0, -2. From here, we can use the slope information. So we have a slope of 5/6. Remember that the number in the numerator, or the top position of that fraction, is your vertical shift. So in this case, since it's a +5, one way that we could look at this would be we're going to go up 5 units. And then in the denominator, or the bottom half of the fraction, we have a +6. So that tells us that we should go to the right 6. So one of the ways that we can do this would be starting at our y-intercept. We could go up 5 units and then go to the right 6 units. And then as you can see, that's how we got that point. We could also go in reverse from the y-intercept point. So instead of going up 5 units, we could go down 5 units. And then instead of going to the right 6 units, we can go to the left 6 units. And as you can see, everything still lines up, and we still have all 3 points line up to give us a straight line. So what I would encourage you to do actually is make sure that you do put at least 3 points on your graph to make sure, or to check, that your line is correctly graphed. So for our second problem, we have 5x minus y is equal to 3. So this is in its standard form. In other words, we have both variables, the x and the y, on one side of the equation. So in order to get this into slope-intercept form so that we can easily identify the y-intercept and then the slope, we'll go ahead and we will subtract 5x from both sides. That would give us -y is equal to -5x plus 3. So we're not done yet, because technically there is a -1 being multiplied with that y, hence the reason why we're looking at a -y. So we want to clear that out, and then we can do that by dividing each term by a -1. So this would result in y is equal to a now positive 5x, because it's a negative divided by a negative, minus 3, because we have a positive divided by a negative. So from here, we can now identify that our y-intercept is going to be at 0, -3. And then we also know that we can either choose to go up 5 units and then to the right 1 unit, or we could choose to go in reverse and go down 5 units and to the left 1 unit. This last problem is just asking you to review how to find the slope when you are given 2 points. Go ahead and work on this one, and when you're ready, press play and we'll review. So when we are trying to find the slope between 2 points, what I would suggest doing is identifying which point you're going to be your first point and which one will be your second point. And that's what those subscripts are meant to represent. So the ones are just saying this info is coming from the first point, and the sub 2s are coming from the second point. So I went ahead and I also included the standard form of that slope formula, just so I had it as a reference. And this allows me to quickly plug in my values, as you can see. I did color code them as well, so you kind of want to make sure that if y2 is first in your subtraction, then x2 should be right underneath it. It should never be diagonally away from it. So if you're using colors, you want to make sure that those colors are stacked on top of each other. Taking care of that, I get -11 over -33, and I should also note, if I can reduce this and clean it up, I should. So after reducing and cleaning this up, I get +1/3 as my slope. All right, you are ready to move to video 2.